Good morning, students. Can you hear me?
Yes, ma'am.
Okay. As all the students will be joining in few minutes, 1 to 2 minutes, I will be starting my lecture. So today's topic is UML. We're studying about what is UML, what are the various diagrams in UML, and how we can draw these diagrams, how UML will be helpful to us, and what is the basic difference between a DFD and a UML. That is the basic concern. What is the difference between a DFD and UML? In the last lecture, we have discussed about the DFD, that is data flow diagram. And today we'll discuss a little bit about the previous lecture, that is DFD, and a new lecture that is related to this object-oriented design, that is with the help of UML. That is called UML is called Unified Modeling Language. So, uh, starting this lecture, Everybody, I hope everybody can see the screen now. The topic object-oriented analysis and design using UML. Can you see my screen as well as can you hear my voice? Everybody.
Yes, ma'am.
Okay. So first of all, what is this UML? UML is Unified Modeling Language. Basically, it is a standard diagramming notation and sometimes referred to as blueprint. It is not an object-oriented analysis or design or a method. It is only a notation for capturing objects. UML is a language independent and analysis and design provides software blueprints captured in UML. So as I already told you, we were discussing data flow diagrams. So why the need for UML arises? First question is, we were discussing data flow diagram, we were discussing structure chart earlier, and they both are, we can say they both are diagramming notations that tell you about modules and data flow. We know that in case of structure chart, we were talking about these the modules, how modules interact and all these things. In case of flow diagram, we were discussing about the flow of data from one process to the another process. But in case of this UML diagram, why the need for UML arises? Basically, unified modeling language is a diagramming notation. This is a diagramming notation like structure chart and a data flow diagram. But this unified modeling language applies to object-oriented concepts, object-oriented analysis, and object-oriented design. It is not object-oriented analysis. It applies to object-oriented analysis and object-oriented design. It is language independent. Why it is called language independent? We are saying it is a unified modeling language. On the other hand, we are saying it is language independent. It is just a modeling language. It is not some kind of programming language. We mean that it is free from programming language. We can have any language like C++ or any Java or any object-oriented language can be used after design in UML. That is the main thing. That you are to draw the various diagrams in UML, and after understanding all the required analysis and design of the object-oriented concepts in UML, you can move towards coding phase, whether it's a C++ or whether it's a Java or any kind of other language you want to use for your coding. Analysis and design provide software blueprints captured in UML. Blueprints serve as a tool for thought and as a form of communication with others. Object-oriented analysis is an investigation of the problem. During object-oriented analysis, there is an emphasis on finding and describing objects in the problem domain. For example, I'll talk about in the case of library information system, a book and library are objects. So we will be talking in terms of book and library and how they are interacting with each other. Object-oriented design emphasizes a conceptual solution that fulfills the requirements need to define software objects and how they collaborate to fulfill the requirements. For example, in the library information system, a book software object may have a little attribute and a get chapter method. So in object-oriented design, we are concerned with objects and their attributes as well as their methods. We know what is object, what is class. We are done with C++ and we know the concept of class. We know the concept of object. But how these things will be implemented in a modeling language before moving towards the coding language in C++. That is the concern here. Designs are implemented in a programming language. In the example, we will have a book class in Java. This is one of the example of converting a modeling language into a design language. In a UML, we have basic three phases. First is analysis, other is design, and third is construction. Analysis applies to investigation of the problem. design is the logical solution, and construction is a code to that problem. Suppose in case of analysis or investigation of the problem, we have book concept, that is a domain concept, but that means how we analyze the thing in a library information system, everything will be revolving around the book concept. So the domain is defined as book. But moving from analysis to design, as you can see on the slides here, we are moving from analysis to design, that is from book, that is simply a concept, to a book called object, that is, or a class that has two parameters, title and print. Title is an attribute and print is a method. And you can see on the third side below the construction code, you can see that we have created a class called book with two members, data members, public void print and private string title. So this is a representation in the form of a code, and how we can move this, you can easily analyze the things that you need to define first in your problem. In your problem, in any problem, suppose I'm talking about university management system. If I has a university management system as a problem, and I want to draw the UML diagram, or I want to do object oriented analysis, object oriented design and object oriented programming, you need to do analysis first, then design, and then programming. So in case of analysis, student in the university management system, student will be called as concept or a domain concept. Moving towards this, in the object, this is, we are talking in terms of object oriented analysis. In case of object oriented design, this student will be like a, will be represented in the form of a class having a student ID, student name, and some function add, delete. This will be called as object oriented design form. And after that, if I'm doing some kind of object oriented programming, then that will be public student, public class student, and its data members like public void add, private or public string name. So what UML is, it is all about analyzing and designing and leading towards programming. UML is a combination of object oriented analysis and design. It is not about programming, because we are to do programming in programming language like C, Java, or any kind of such languages like Python. But UML specifies the concept of object oriented analysis design these concepts into some graphical notation, or we can say in a diagramming form, is called UML. There are set of proven design solution to problems that are considered best practices. We'll be discussing these things, certain groupings of classes with specific responsibilities. We need to define responsibilities of all those classes. We'll be discussing what will be used to combine the classes or interacting different classes and all these things. These provide specific solution to specific problems called design patterns. We will discuss these patterns and how to apply them to develop solution to problems. So of course, design solution to requirement assumes a robust requirement analysis, as we have taken place. Use cases are often used to capture stories of requirement. So we'll be discussing the various diagram, and one diagram is use cases, and it is told that Why we are using use case, we'll discussing that in future in the coming slides. They are often used to capture stories of requirement. Use cases are not specifically designed to be object oriented, but rather are meant to capture how an application will be used. While there are many methods for capturing requirement, we will concentrate on use cases ahead. Our approach. While designing or analyzing, we need a requirement analysis approach with object-oriented analysis and object-oriented design that need to be practiced in a framework of development process. We will adopt an agile approach. We know that we have studied an agile approach. Whenever we are dealing with any kind of concepts related to object-oriented analysis and object-oriented design, that we are in agile approach, which can be used as a sample iterative development process. Within this process, the principles can be discussed. And I told you in case of Agile, there are different models like Scrum, feature-driven development, lean development, crystal methods, and others. Now, unified process. This UML is called the unified process and is a popular iterative software development process. Like we have studied about iterative and evolutionary development that involves the relatively early programming and testing of the partial system in repeated cycles. It typically also means the development start before the exact software requirements have been specified in detail. So feedback is used to clarify, correct, and improve the evolving solutions. So what is unified process? Unified process is extreme programming basically, and very flexible and open and can include other practice forms. So extreme programming, that is basically called as XP, is test driven development. Refactoring can fit within a unified programming, extreme programming. Being pragmatic in adapting a particular process to your needs is an important skill. All projects are different. While we'll be studying all the topics, we will be studying object-oriented design. Today, we'll be studying about the UML notations, requirement analysis, iterative development. We are done with that. Principle and guidelines and patterns. So first of all, as I already discussed a little about object-oriented analysis and design, OOA, that is object-oriented analysis, we define, find, and describe objects or concept in the problem domain. In case of object-oriented design, we define how these software objects collaborate to meet the requirement, that is attributes and methods. And in case of object-oriented programming, implementation is the concern. We implement the design objects in the form of Java, C++, or C# languages. The object-oriented system development lifecycle. Like a simple traditional lifecycle, we have object-oriented development lifecycle. And that lifecycle consists of analysis phase, design phase, and implementation phase. From the analysis phase, it models the real world applications developed using showing its important properties. Models specify the functional behavior of the system independent of implementation detail. Design phase. While after doing analysis, model is refined and adopted to the environment, and that concept is called design phase. And after doing design, what we are doing is we are moving towards the implementation phase. That is basically conversion of a design in the diagrammatic representation to the coding phase, and that is called the implementation phase. That may involve some front end and a back end. So that is basically concerned in the implementation phase. Object-oriented system development lifecycle consists of UML. UML, a notation that allows the modeler, like we people who are doing work in the UML, modeler to specify, visualize, and construct the artifacts of software system as well as business models. Techniques and notations. The various techniques and notations or the diagrams used in UML are use cases, class diagram, state diagram, sequence diagram. Use case modeling is applied to analyze functional requirements of the system. Performed during the analysis phase to help developer understand functional requirement of the system without regard for implementation details. So if we are going toward use case modeling, what is basically use case is, why it is called a use case, what are the various components of use case. A use case is a complete sequence of related actions initiated by an actor. Actor is a person that is using that particular software or a problem or is a part of that very problem. Actor is basically an external entity that interacts with the system. Use case modeling. To model a system, we need to capture the dynamic behavior. Dynamic behavior means behavior of the system when it is running or operating. Only static behavior is not sufficient. To model a system, rather, a dynamic behavior is more important than the static behavior. Every time, whenever we are considering any problem for implementation or developing any kind of project, we are into two conditions. What things will be static, what other things will be dynamic, and how we are moving towards from static to dynamic, whether static is more important or dynamic is more important. So these are the questions that comes in our mind. Only static behavior is not sufficient to develop any kind of project or model. A system should need to understand a dynamic behavior of a system, of the uh, entities, dynamic behavior of the entities. In UML, there are 5 diagrams available to model the dynamic nature, and use case is one of them. In case of UML, we have 9 diagrams actually, and out of the 9 diagrams, 5 diagrams are available to model the dynamic nature of the UML or the system under consideration. Use case diagram is one of them. Or out of the 5 diagrams, we have one diagram, and that diagram is called use case diagram. Now, as we have to discuss that the use case diagram is dynamic in nature, as I told you that this is dynamic in nature, there should be some internal or external factors for making the interaction. These internal and external agents are known as actors. The people who are interacting with the system are called actors. Use case diagram consists of actors, use cases, and their relationships. The diagram is used to model the system, subsystem of an application. A single use case diagram captures a particular functionality of the system. I'll draw a use case diagram on the board. Before that, I'm just giving you an introduction. What are the components of the use case diagram? A single use case diagram captures a particular functionality of a system. Hence, to model the entire system, a number of use case diagrams can be used in the single project or a single system. Use case modeling, it totally represents the functionality of the system, may participate in the relationship with other use cases, and may also use other use cases. So while doing use case modeling, we should know that it describes functionality of the system, how the system is going to function. So that will be totally a dynamic kind of performance we need. Use cases may participate in the relationship with other use cases, so the different use case can interact or can relate with each other. Use case may also use other use cases. So that is the concern, that use case can use other use cases. This is a use case diagram, sample use case diagram. In the diagram, in the presentation, you can see here, this is a dynamic behavior that is shown for order management system. Like we are to draw, if I am a customer and I am ordering something from online system or from the restaurant or any kind of ordering management system, you can see here this stick man represents the customer. This stick man represents the customer, and this oval shape represents the use cases. Here you can see the customer is called an actor. In the diagram on the screen, you can see everybody. I hope everybody can see the diagram on the slides here. This is the customer, the stick man. And these three, like order, special order or normal order, these are the use cases. In this diagram, the main use case is the order. Customer is ordering something, that is the order. And what is this extend relationship mean? This order may be a special order or a normal order. So we can extend a single use case into a further use case, and that kind of concept is called extends. From the extend, we mean that what we are doing is we are extending our use cases so that we can get into the inner detail of the system. Like this is some use case. If we are extending, we are making it some kind of specialized use case that will be called as extend, and they are represented with the relation written above it called extend. So this is a form of representation of any use case into further, we can say further types. This use case is further divided into two types. Like in case of order, what I'm doing is I'm extending this use case into whether this order is a special order or regular order or normal order. So whenever you are extending any kind of use case, you need to write this extend on the arrow of that very use case. This is called extend relationship. And I'll draw here because you can better understand if I am drawing here rather than showing on you the slides. Suppose this is restaurant management system. One is order, other is generate bill, or there is something like that. Suppose this is customer, this stick man is customer, or we can say this is actor. These are two use case. So this actor, this customer is giving order, and on the other side this manager, or we can say is generating a bill. So this is a kind of we can say this is a use case diagram in which this actor is giving an order and this manager is generating the bill after getting an order. This is basically a diagram. But if we want to put more detail in our use case or every kind of detail in a use case, what we can do is we can extend this use case. And for extending this use case, we use a term called extend relationship. So in the diagram on the PPT, you can see the order use case is extended. So this box defines the boundary of that very use case. This is the boundary of that very use case. Here in the PPT, only a single use case is extended to special order and normal order. But it is up to the developer, or we can say up to the modeler, how many use case he or she wants to put in his or her work. Because every kind of detail, every kind of dynamic behavior is to be shown in the form of diagrammatic representation for better understanding of your problem. That is the concern. This is the system boundary. These are the actors. These are the use cases. So a single use case or a use case consists of actors, use cases, and their relationships with other use cases. If this has some relationship with this use case, that also be that need no and the net need to be defined also. If this is having further detail, so this is defined using the extend feature. So that is the relationship of one use case with the other use case. I hope everybody has understood what is use case and what are the use case diagrams and how we can draw the use case diagram if we are given some problem in the exam. Pardon? Is there any issue related to use case diagram, class? Can you hear me? So this is the another diagram here in the university registration system, and you can see here in the university registration system we have student, we have office here, that university office. This is the registration clerk and this is instructor. There are four stick men and these represent the actors. In the we can say not in the boundary, before that the boundary. This is student one, student. This is the office, university office or the registrar office or any. This is the registration clerk and this is the instructor. Here you can see a student is coming and registering in class. So class registration is extended in two forms, whether this class registration is for special class or a pre-required course is not completed. So this use case is extended in two forms, so that is why we have used here the extend a relationship here. And this instructor is teaching to using this use case registration for special class. That means this instructor is given a duty to register for special classes. And on the other hand, you can see office. This office is generating student bills related to registration or fees. And this registration clerk is responsible for class registration of student. So that means student is aware whether he is registering for the special class or if or pre-required course is not completed. And the registration clerk is also aware of the pre-required course is not completed. And you can see here 1 1 1 1 everywhere. That means this has one-to-one relationship. That means a single student is registering in a single way. I mean single registration is done using the this university registration system. And one, there is one clerk, that is a registration clerk. So one to one kind of interaction is there with the use case and the actor here. So that is the basic concept of drawing use cases in the university registration system. This the whole picture is representation of the university registration system in the Microsoft Visio. Here you can draw this Microsoft you can also draw use case diagram in the software called Microsoft Visio. This software is freely available on the internet, so you can also install and can draw use cases of your problem under consideration. Now next is object modeling, or we can say the class diagram. But before moving toward object modeling, we are moving towards one of our poll for today. Kindly answer these questions. All are required to answer these questions. Can you see on the screen? Class. First question is, the unified modeling language is a programming language or a diagrammatic notation. Next is, there is an emphasis on finding and describing the objects in the problem domain. Whether it's object oriented analysis or object oriented programming, all are required to answer these questions. Kindly be fast, you're taking a lot of time. I'm ending this poll in 20 seconds, next 20 seconds, after 20 seconds. So I am ending poll here. The unified modeling language is a diagramming notation. Another one is dash. There is an emphasis on finding and describing. This is basically object oriented analysis. There is an emphasis on finding and describing objects in the problem domain. So next is object modeling and class diagram. We know what is object. Object, an entity that has a well-defined role in the application domain and has a state and behavior and identity. A state is a condition that encompasses an object's properties and the values those properties have. A behavior, a manner that represents how an object acts and reacts. Object class, a set of objects that share a common structure and a common behavior, or a simple class is called object class. Now, next diagram, and that diagram is class diagram. Class diagram is a static diagram that represents the static view of an application. Class diagram is not only used for visualizing, describing, or documenting different aspects of a system, but also for constructing executable code for software applications. Class diagram describes the attributes and operations of a class and also the constraints imposed on the system. The class diagrams are widely used in the modeling of object-oriented systems because they are the only UML diagrams which can be mapped directly with the object-oriented languages. So class diagrams are very important, though they are the static diagrams. They do not represent the dynamic behavior of the system, even though they are very much important for object-oriented concepts. Why? Because we are able to map them directly from their diagrams to object-oriented languages like C, C++, Java, C hash, or C++, Java, and C hash, not C language. Class diagrams show a collection of classes. All these are interacting, their interfaces, their association, their collaboration, and constraints. It is also known as structural diagram. The other name of the class diagram is the structural diagram. Class diagram or class is represented as a rectangle with 3 compartments, and objects can participate in the relationship with the object of the same class. So every class diagram has a number of classes, in a single class diagram. Always remember this thing. There will be there is a number of classes to represent a class. It has 3 compartments. The first compartment represents the name of the class, name of class. Second represents the attributes or data members, and third represents the methods data members. So these are the 3 compartments that are there in the class of a class diagram. In class diagram, there may be a number of classes who are interacting, associating, and sharing some kind of data between them. From this class diagram, what we do is we map this class diagram into classes in the object-oriented programming. And from these class diagrams, we can easily draw the object-oriented diagrams. Objects can participate in the relationship with the objects of the same class. This is one of the diagrams shown here in the slide. Here you can see. Here, the same diagram for which we have drawn the use case diagram. Now we are showing here the class diagram. You can see there is a customer class and an order class. Earlier, this was shown using actors and use cases. Now, in case of a class diagram, we are showing the static behavior of the system. So we have a class called customer. and another class called order, customer, and other class called order. Whenever we are talking in terms of a customer, we will analyze what are the things we need to know about the customer. It is name, their location, and what are the methods. Like from the method we mean what kind of operations the customer is going to do or going to uh, operate on. Like customer will be in the form of getting an order or sending an order. If I am sending some order on the online system, that is the duty of the customer, or we can say operation done by the customer. And after ordering, I am getting that order, that is other thing is receiving order. So in case of customer, we will need to have his name, customer name, customer location, and receive order, send order. These are the two things, receive order and send order. On the other hand, in case of order, we need to have date of that very order and number of that very order. What will be the number of an order? Whenever we are placing some kind of order, we know that this is the number of an order. That is why we have used that number of order. The operations on that order will be whether we are confirming order, whether we are cancelling into cancel, or we can have another thing also, close. So we have defined two classes. One is called customer class and other is called order class. Data members, member functions. Data members, member functions. So after defining every class, next operation is to define their association. Association is a customer, a single customer can place n number of orders. A single customer can place n number of orders. So this class is interacting with this class in the form of 1 to n. We can have n here, we can have 5 here, we can have star here. From 1 to n means n any number that is a fixed number. Or we can have asterisk here any number of multiple. And 5 means a particular customer can order up to 5. Particular customer can order up to 5 orders. That is a concern. So we need to define the association between the classes in the class diagram. Next is superclass, the concept of superclass and subclass. This is the order class, and we know this order class is the generalized class. We want to make some specialized classes from this generalized class. The thing is, we can have specialized classes like special order, or normal order. So this, if these are the specialized classes, we will call at the as these classes are coming from inheriting the properties of this class, we'll say this is subclass. Other one is also subclass, and this is called super class. And this concept will be called as generalization, and we have studied this generalization in DBMS also. This is generalized class, this is specialized class. So we can show in our problem, like any problem for which we are doing drawing the class diagram, the concept of generalization and the concept of specialization. Are these things are enough? These associations are enough in the class? No. these associations are not enough in the class. We need to have more associations. In the diagram here, you can see this order class is having two special classes like special order and normal order. In the special order and in the normal order, you can see in the diagram shown here, this has a date and number data members, and you can see the member functions. These member functions are there, and some of the member functions are new. These are the new functions like dispatch and receive. So we can have special added function in the subclasses that are inherited from the superclasses, or class that are inheriting from the super features of both the class class feature as well as the feature of the parent class. Next is object modeling. Object modeling is totally based on object diagram. Object diagram means a graph of instances that are compatible with the given class diagram. We know any instance of a class diagram is called object diagram. So all the instances represent all the object diagrams. But can we draw all the objects on the object diagram? No. We need to show a single instance in the object diagram. Object is represented as a rectangle with two compartments. Operation. A function or service that is provided by all the instances of class. And encapsulation, we know what is encapsulation, the technique of hiding the internal implementation details of an object from external view. From external view, we need to hide all these things. Object diagram represent an instance of a class diagram. The basic concepts are similar to class diagram. Concept is similar as the class diagram. And object diagram. Object diagrams also represent the static view of a system. You need to understand how we can show a dynamic behavior of a system and how we can show the static behavior of a system. Classes and objects and class diagram and object diagram represent the static view of a system, but this static view is a snapshot of the system at a particular moment. Object diagrams are used to render a set of objects and their relationship as an instance. So this is the object diagram of order management system. You can see customer is interacting with the order, and there are three order, or we can say three numbers, three objects or three instances. A single customer has placed three orders with the number 1, 2, 3, 2 and 4, 0. So O1 is the first order, O2 is the second order, O3 is the third order. And you can see out of two orders like O1 and O2, there are two special orders, S1 and S2 with the number 20 and 30. And further there is a normal order with the number 60. So this way you can show, you can map from the class diagram towards an object diagram. This is an example showing class diagram, showing two classes and how they are interacting. Like in case of UML diagram, this is a student class and a course class. So again, I am showing you another example. Student class has name, attribute, date of birth, year, address, phone number, their age, calculation of age function, GPA calculation, and registration for course. On the other hand side, we have a course class which has a course code. As we in our class we have a course code, course title, course hours and enrollment. These are the data members and these represent the operation. That is, in the course we have enrollment. We can enroll for a particular course. The student can enroll for a particular course. So this is shown here in the form of a class diagram, that student is interacting with the course class. On the other hand, you can see here the student Mary Jones. This is a representation in the UML. You want to write, or if you want to draw object, you need to write like this: the object name colon and name of that very class, student class. So instance of student is object Mary Jones. So Mary Jones is object name colon class. Object name colon class name. Name is Mary Jones. Date of birth is this. Year is this. So these are, if you are writing their value, that means you are into the object diagram with the two instances. You can see this is the two instances shown here. On the other hand side, this course class has object, course code, course title, and the credit hours for that particular course. This is the object diagram of a course class. Representing associations. What is association and how we can use association and what are the rules for association? An association is a relationship between object classes. We have classes, objects classes, and their relationship. That may be a unary relation, that degree may be a binary relation, ternary, or any high kind of relation. And they are depicted in the form of a solid line between the participating classes. In the previous diagram, you can see here, these are the solid lines, and this is association between the two classes. Association rule. The end of an association where it connects to the class. Where it connects to a class. Each role has multiplicity, which indicates how many objects participate in given association relationship. As I have already shown you, this is the association. Association is that n is the order. An order can be assigned to a particular customer, and a particular customer can place n orders. So this is the association. Single per customer, n orders. This is the association between the two classes, and that is represented in the form of association rule. Each role has a multiplicity, which indicates how many objects participate in a given association relationship. Like a person is married to a person, 0 or 0, 0 to 1. A 1 person can marry a 1 person, or a 0 person can marry a 0 person. Why it is shown in the form of 0 dot dot 1? It means that the range is from 0 to 1. Either the person is married, either the person is not married. If the person is not married, the value will be 0. And if a person is married, the value will be 1. There may not be a value more than 1. One person cannot marry two persons. The concept is from 0 to 1, there is mapping from 0 to 1 to 0 to 1. A person is married to person. So it is shown in the form of a loop. Here you can see if there is an employee is managing and managing anything. 0 to 1 manager can manage n number of employees. 0 manager to 1 manager. Either there is a manager or there is no manager. If there is no manager, there are only employees. Or if there is one manager is managing n number of, this star represent, asterisk represent n number of employees. N number of employees. Manager manages employees. It is like this form. Manager manages employees. And then in this diagram, you can see employee 0 to 1 employee is assigned parking place 0 to 1. Either employee is assigned a parking place or not. That will be called as 1 to 1 relationship. Product line is assigned a product 1 to 1 to 1 to many. This is 1 to many relationship. This contains, product line contains a product. Either it contain one product or it can contain more than one product, that is represented in form of asterisk. Next is one many to many student course. Like we are registering for online courses. So in that case, a number of students can register a number of courses. Any number of students can register any number of courses. So many to many relation is shown here in the form of asterisk to asterisk. This is the association. These are all examples of association. Here you can see this is also an example of association. So in that case, you can see this is a binary relationship. This is a unary. These are the unary relationships. 1 and 2. These are the singular relationship. Person is managing or married to a person. Manager is managing an employee. Manager is also an employee, and manager is managing employees. This is unary relation. When there are two entities involved, we will say this is binary relationship. And when there are three entities involved, like part, vendor, warehouse, this relationship is called ternary relationship, as it has these three uh, entities are interacting with each other through the supplies. Vendor supplies warehouse, a vendor supplies a part of the warehouse. These are they are having many to many relationship. Generalization. Abstraction of common features among multiple classes as well as their relationship into a more general class, that is called generalization. Subclass, a class that has been generalized. If a particular class has been generalized, is called subclass. A superclass, a class that is composed of several generalized classes, is called superclass. Representing generalization, we know there is a discriminator shows which property of an object class is being abstracted by generalization relationship. Inheritance, a property that a subclass inherits the feature from its superclass. We know what is inheritance and we know what is abstract class. A class that has no direct instances but whose descendants may have direct instances is called abstract class. उसके अपने कुछ instance नहीं, it does not have a any value of its own, but its descendants may have direct instances. That class is called abstract class. Concrete class, a class that can have direct instances. So you can see in the diagram here examples of generalization, inheritance, constraints, employees, superclass with three subclasses. This is the employee class, you can see, and there are three classes. Like if a person is employee, he has some address, name, date hired associated with it. This employee can have these specialized classes like hourly employee, whether it's a salaried employee or a consultant. So this is the type of employment, whether it is an hourly employed, employment type is or salary employed or a consultant. You can see here this if it is hourly employed, we should have a hourly rate as data member. If it is a salaried employed, we should have annual salary stock option as data member. And if it is a consultant, contract billing rate, what is the contract billing rate? How he interact with the people or make contract with the people and how he charges. So in every case, we are if it is an hourly employee, we'll calculate pay based on per hour. We can compute the wages. If he is a salaried employed, his annual salary will be calculated and he will contribute into the pension. If he is a consultant, we will compute the fees of that very particular class here. So this concept of dividing this class, generalized class, into some specialized class, this arrow represents the concept called generalization. This is generalization concept. Next is uh, showing the concept of generalization as well as inheritance. This patient class is shown here. It is also represented using the generalized class here. You can see the specialized class is outpatient or a resident patient. So these are the specialized classes. Check date, back date, date discharged, and this class, the resident patient, this is a further class. This class has association with the bed class, and then this association is from 0 to 1 to 1. Either resident patient has 0 bed or 1 bed. It may not have single resident patient cannot have more than 1 bed. This is a form in which we can represent the generalization, inheritance concepts in the class. If you are able to draw such kind of classes or class diagram for your particular problem, it will be easy for you to convert this object oriented analysis, object oriented design into object oriented programming. Earlier, what we were doing in our previous years, in the first year or in the second year, we were doing, stop doing this thing, the leap. Earlier we were discussing these things, we were doing object oriented programming in a simple way, but whenever there are numbers of classes like 40-50 classes, we can do such thing in the form of uh, uh, in the form of this UML diagram, this form of class diagram. Is that clear to everybody? Or is there any issue you are not able to understand, or if you have any queries, you can type in the chat box, or you can raise hand. We'll clear your doubt regarding this class diagram, use case diagram. Can you hear me? Students, are you able to listen me? Can you hear me?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Is that topic clear to everybody related to
Yes,
Yes,
ma'am.
use
ma'am.
case diagram and class diagram and what are object diagrams? Next is aggregation. Now aggregation is whenever we want that there should, we want to show a part or whole or a part of um, any class or any relationship, we can show in the form of aggregation. You can see here in the there is one example representation here, like a diagram is drawn and the symbol is like the diamond form. This is in a hollow diamond. This personal computer has CPU, hard disk, monitor, and keyboard as part. So whenever you want to show a whole part relationship or a part relationship between a component object and an aggregate object, you can show in the form of aggregation. So in the case of personal computer, in the case of personal computer here, you can see they have shown you a association, we can say a relationship, not association, because association is also one of the relationship. Whenever we want to show relationship between classes in the form of part and whole, we can represent in the form of this diamond. On the diamond side, on the diamond upper side, this represent whole, whole, whole of any object, and this represent the part of that very object. And like a car, if I write here car, car has different component like brake, gears, engine, such kind of things. So this car is whole and these are the components. So we want to show some kind of representation in, we want to show whole part relationship in the class diagram. We can do in this form. Like in the diagram on the screen here, you can see this personal computer has CPU, hard disk, monitor and a keyboard. So that means a personal computer can have 1 to 4 CPUs. Okay? We can have more than one CPUs in our personal computer. More one to any number hard disk. We can attach any number of hard disk and monitor and a keyboard. So you can see how can we show this thing in the form of aggregation is. So this represents aggregation. Aggregation. The simple arrow represents association. Specialized class or generalized concept is shown in the form of generalized and specialization. A simple arrow also represent, without an arrow also represent between two classes the association concept. So we should be clear with the aggregation, association, generalization and specialization. Next is dynamic modeling and the state diagram. Before moving towards this dynamic modeling and state diagram, we'll have a poll here. Kindly answer these questions, and after that we'll do dynamic modeling in the form of state diagram. You are required to answer these questions. All must note that if anybody annotate on the screen, he or she will be removed from the class and will enter the class only with the permission of the HOD. First is dash that allows a modeler to specify, visualize, and construct the artifacts of software system as well as business models, whether it's a unified modeling language or C++. Next is dash performed during the analysis phase to help developer understand functional requirements of the system without regard for implementation details, whether it's a use case diagram or class diagram. Kindly answer these questions. I am ending this poll in after 10 seconds. Use case modeling in the second question, whether it's a class diagram. In the first question, that allows the modeler to specify dash, that allows the modeler to specify, visualize, and construct the artifacts of software system as well as business model, whether it's a unified modeling language or C++. So I'm ending poll. First is dash that allows the answer is unified modeling language. In the case of second, the performed during the analysis phase to help developer understand function requirement of the system without regard for implementation detail. This is use case modeling. Now moving ahead, dynamic modeling and state diagrams. A state is basically a condition during the life of an object or during which it satisfies some conditions or perform some actions or wait for some events. It is shown as a rectangle with rounded corners. State transition, the changes in the attributes of an object or the links of an object has with other objects, shown as a solid arrow diagram with a guard condition and action. What is event? We should know what is state, how state transition takes place, and what are the events. Event is something that take place at a certain point in time. So this is a state diagram for the student object. You can see here, as I told you, the state is a condition during the life of an object, during which it satisfies some conditions, perform some actions, or wait some events. So it is shown in the rectangle with the rounded corners. So you can see here, this is the state diagram where we have shown the various states, and with the states you can see the rectangle with the rounded corner. So these are different states of particular student object. Inquiry, student is doing inquiry, is applying, applied, rejected, approved, withdrawn, confirmed, matriculated, graduated, dropout. So a single object, student object, can have any number of states, and they are shown with this rectangle with the rounded corners. And from the state we have state transition. State transition is that we are changing from one state to the other state, that is called state transition. And event is that is something that is triggering at or taking place at a certain point in time. So a condition during the lifetime of an object, which it satisfied some condition, perform some actions, or wait for some events. It is shown as in a rectangle with the rounded corners. State transition, the changes in the attributes of an object or links an object has with the other object. It is showed using an solid arrow or diagrammed with a guard condition and action. An event is that is taking place at a certain point in time. So this is a state diagram. Student inquires for the inquiry. After inquiry, what it will do? It will submit an application. After submitting an application, in the diagram on the screen you can see, after submitting an application, it applies, and that is called, it applies for some course, and that is condition is called applied. So, and after applied, the status is applied for a particular student, it has to further states either it will get approved or it will get rejected. Rejection letter will put it into a state called rejected, and applied will put into approved will be put into a status to whether he want to move forward in the form of confirmed, or whether he wants to withdraw or denies admission for. So that is basic the condition shown here. So after inquiry, it submitted, student submitted application. After application is applied, it will have two options. Either it will be get rejected or approved. After approval, it has two further conditions like states confirmed or withdrawn. If it is confirmed, it will have it. The college will issue the admit card and student ID information. After matriculated, after graduated, it will be called, after matriculated it will be called as graduated, completing all degree requirements. And after matriculated it may drop out in between or leave the school in between. So these are shown in the form of states here. These represent state. This arrows, red arrows represent the state transition. This red dot represent initial state, initial condition. This red with the circle represent the final state. This red with the circle represent the final state. So you can see here there are three final states. This either get rejected, withdrawn, or inquiry. After inquiry, stop for further action. So these are the different states. This arrow represents state transition. State transition means what kind of transition is occurring. Inquiries, submitting application, rejection letter, accept admission offer, denies admission offer, withdraw admission acceptance, reaccept offer, issue admit card, complete all degree requirements, leave school. So this is a state diagram for student object. Like this, you can also draw a diagram for uh, like book object or any other kind of odd, any kind customer object. You can also draw different states of a person in the problem domain. Next is dynamic modeling behavior called a sequence diagram, and this is very important. This sequence diagram. What does this sequence diagram represent? Sequence diagram is a depiction of the interaction among objects during certain period of time, and it has activation and messages as components. Every sequence diagram has activation and messages as components. Like that activation is the time period during which an object performs an operation. Whenever that object is active or doing some kind of operation, that is called activation. Messages means by which objects communicate with each other in the sequence diagram. Sequence diagram has two types of usually message: synchronous message or a simple message. In the synchronous message, we mean a type of message in which the caller has to wait for receiving object to finish executing the card operation before it can assume execution itself. Is called synchronous message. A type of message, I'm repeating, a type of message in which the caller has to wait for the receiving object. The calling object has to wait for the receiving object to finish executing the called operation before it can assume execution itself. A simple message is a message that transfer control from the sender to the recipient without describing the details of the communication. So there may be a synchronous message or a simple message. You can see a sequence diagram here, and this represent, these yellow boxes represent the objects here. Registration window, registration entry, course, student. These are the things that are shown here in the diagram. Registration window, course offering, course and student. Registration window first get opened, and after opening this registration window, next is enter class, student class details, and student is registering. Registration entry, course offering, check if a particular course is open. If that particular course is open, will register for that particular course, and check if open true, exist prerequisites condition. If it is not true, it will return a false value that this course is not open. If it is able open, student can register for a particular course with the details, and after course registration, student will check for a new registration here. You can see the new registration here. So after registration, it will return that particular value that it is registered. And after this new registration, all that things are done, it will return confirmed registration on the window here. So these are in the sequence diagram. Again, I'm repeating. Sequence diagram is in the form, in the sequence diagram we have activation and messages. This blue line represents the activation, and these are the messages that are represented shown here. Arrow here represent this message moving from this way to this way, and arrow this represent this message moving from right to left. Earlier it was moving from left to right. Every left to right will have an opposite arrow from right to left of the message. That is the thing here shown in the form of diagram. Registering and registration count. So this registration window activation is long line, blue bar, that this is active for a opening to confirmed registration. And this thing is active in this stage only, like course offering. This course is active for a particular stage only. When this window is opening, this course and course offering student is not active. After registration entry, whether a particular course is open or not is checked and it becomes active. These are the course being offered. After the course offering is seen by the registration, the student, it will further register for a particular course. So this is active for a particular moment of time. After that, a student is active. If there is a new registration, that will be active for that longer period, period of time, and it will return the confirmed registration. So in this way, this will work in the case of sequence diagram. Moving to design, starting with the existing set of analysis model. If we are moving towards design, like we have described the design here, we are moving towards design. Start with the existing set of analysis model. We should have a particular analysis model in our hand. Progressively add technical details. Don't move aggressively, move progressively. Add little bit details in every diagram. Add technical details. Try to add the technical details. Design model must be more detailed than analysis model. So always remember one thing: when you are into the analysis phase and whenever you are into the design phase, analysis may not have those details, but design should have more details, because this design will be converted into the programming concept or programming language. Component diagram. Apart from this use case diagram, class diagram, object diagram, sequence diagram, state diagram, we have component diagram, deployment diagrams. What is this component diagram? A component diagram that shows software components or modules and their dependency. That is called component diagram. Next is deployment diagram. A diagram that shows how the software component processes and objects are deployed into physical architecture of the system, so that how this software component will be processed and how objects are deployed into physical architecture of the system is called, how these will be deployed is called, as the name implies, that is called deployment diagram. So this is one of the picture diagram shown here, component diagram here shown here, that like we have a class scheduler, class registration, and GUI. These are the three components: scheduling the class, class registration, and graphical user interface. Next is object oriented modeling approach. We are done with the use case, we are done with the class diagram, we are done with the state diagram, and after that we are done with the sequence diagram. Before moving towards the further diagram, we'll have a look at these diagram. So I'm starting from the first. Now what we are done with, what are the various diagram we are done with. We know how we can draw the structure chart. Structure chart involves modules of a project. DFT, it shows data flow diagram. We are done with the data flow diagram. We know all the concept 0, 1, 2 level diagram, and we know this 0 level is called context level. This was discussed in the previous lecture, and we discussed 0, 1 and 2 levels, how we have to assign the levels, what are the various ways we can balance a DFD. And in that we also discussed about data dictionary, and that is data dictionary, data about data, and notations that are used. So if my concern is, if you are given a particular problem, can you draw the structure chart for a particular problem? I'm asking from class. Can you draw the structure chart for a particular problem? Everybody? Hello? Can you hear me what I'm saying? Can you draw the structure chart of a particular problem?
Yes, ma'am.
Okay, only Anjali is speaking and nobody else. I hope everybody is able to
Yes,
understand what
ma'am.
I'm saying.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So
Yes, ma'am.
we can draw a structure chart. And if I told you to draw the DFD of your problem, can you draw the DFD of 0 level DFD, 1 level DFD, and up to 2 level DFD of a particular problem?
Yes, ma'am.
Is there any issue related to data flow diagram?
No, ma'am.
You can draw data flow diagram. If I'll give you some problem related to data flow diagram in the class or in the this tutorial or in the assignment.
Yes.
Okay.
Yes, ma'am.
So with data flow diagram, I hope everybody can able to write down the data dictionary, that is basically data about data. Mitesh, can we draw the can we write data dictionary? Can you write data dictionary?
Yes, ma'am.
Okay. And this whole concept was related to the traditional system. Traditional system. Or we can, in the case traditional system means structured programming. Structured programming. Decision trees, decision tables, structure chart, DFD, data dictionary. And today we discussed unified processes, that is unified modeling language, that is UML. And in that I told you that we are just discussing the summary what we have discussed today, and I'll give you problem today by evening, and you are to draw the UML as well as the DFD and structure chart of a particular problem. Next is today we discuss the UML. I told you about the unified process, UML, introduction, about object-oriented analysis, object-oriented design, object-oriented programming. And I told you how this object-oriented analysis differ from object-oriented design, and this how object-oriented design differ from object-oriented programming. Apart from that, I discussed about the static and dynamic behavior of the system. Static and dynamic behavior of the system, and the diagrams that depict static and dynamic behavior of the system. And today we discussed the various diagrams which diagrams? Use case, class diagram,
मैम फर्स्ट वाला शो नहीं हो रहा.
which one? Use case diagram.
Yes, ma'am. The first one.
First is use case diagram. You cannot see use case diagram on the board.
Board is not visible above the class.
Why this is not visible? Let me see. Is there any issue related to net or something that? Okay.
No, ma'am.
You're not, that is above this webcam is, you are not able to see the whole board. Okay.
Yes, ma'am.
Okay. Madam, I should write here only, then you are able to see. Use case diagram. Use case diagram. We know in that we have actors, we have use cases, and we have relationship. That is extend. I have drawn here on the board itself. Next is today we discussed about classes and objects. So we know how classes interact, and we draw the class diagram. And on that we discussed about association, generalization, specialization, aggregation. These concepts, everybody knows these concepts: association, generalization, specialization, and aggregation. Today we discussed about object diagram, how we can map from class diagram to object diagram. Can we draw this class diagram? If any problem is given by me, can you people draw? Yes, class, can you draw class diagram if I give you some problem related to the this class diagram or object diagram? Can you draw this class diagram? Can you draw the association? Can you able to draw this generalization, specialization, or aggregation? Nobody? I hope everybody is able to understand today's topic related to class diagram. Or is there any issue? Nobody is answering me.
Ma'am, it is clear.
Is there any issue related to class diagram?
No, ma'am.
So you can draw this class diagram. Next is object diagram. I told you how can we map from a class diagram to object diagram. We know that this object diagram is instances of the class diagram. And apart from that, we discussed about state diagrams today. State diagrams. Fourth one is state diagram. And fifth diagram today we discussed is sequence diagram. In the last we discussed the sequence diagram. So if you are given any problem, you are able to draw the use case diagram, the class diagram, the object diagram, the sequence diagram, and state diagram. This is the concern. And it will be definitely asked in your paper to draw these diagrams. There may be a single problem for which you have to draw all the use case diagram, class diagram, object diagram, sequence diagram, or state diagram. Or there may be according to a question that draw a particular state diagram for a particular system like university management system. The problem will be given to you like university management system is there, and you have to draw the state diagram, or you have to draw the sequence diagram of a particular university management system, or restaurant ordering system, or library information system, or any kind of such system. It will depend on the examiner what kind of problem he feels like need to give you in the paper. Moving ahead, we'll have one poll here, and after that we'll discuss further. Answer these questions. Abhishek Mahajan. Is there any issue?
Yes, ma'am.
Anji, you can tell
Ma'am,
me.
poll shown you, ma'am.
Okay. I don't know why it is not shown to some people. We'll discuss and I will let you know why it is not shown to you. You have joined recently or from the starting you are
No, ma'am, I have joined from the starting of the meeting.
okay. I'll see that.
Yes, ma'am. Thank you, ma'am.
Hello. Hello.
Yes.
Ma'am.
Yes. Who is speaking?
Ma'am, Amindeep is here.
Okay. Yes, Amindi.
जैसे हम बार-बार Yes, ma'am.
Is there any issue?
Hello.
Hello. Is there any issue? You are not able to see the poll?
Ma'am, I have an issue about network connection. Internet connection.
Internet connection? What happened to your internet connection? You are not able to hear me?
मैम उसके नेट की प्रॉब्लम्स की वजह से मैं बार-बार डिस्कनेक्ट हो जाती हूँ
Okay.
मीटिंग से.
Okay.
Yes, ma'am.
We'll give you the link of that this recording, and you can access afterwards.
No, ma'am. मैम प्रॉब्लम ये है कि मैंने कनेक्ट किया है
Okay.
स्टार्टिंग से किया है मीटिंग लेकिन बार-बार नेट प्रॉब्लम की वजह से
You
डिस्कनेक्ट
got
हो जाता है.
disconnected. Okay.
यस मैम ना इसकी वजह से
That will be recorded in our meeting, whether when you have joined and when you are leaving. Don't worry about these things.
ओके मैम अटेंडेंस की प्रॉब्लम तो नहीं होगी इसमें.
We'll see that when you have joined, it will be recorded in our system, in the Zoom system. Kindly answer these questions. I am ending this poll in 5 seconds. A condition that encompasses an object's properties and the values those properties have, whether it's object, state, or behavior. Next is a relationship between object classes. Degree may be unary, binary, ternary, or higher, depicted as a solid line between the participating classes, whether it's association, aggregation, or generalization. I am ending poll here. So the answer to these questions is first is a condition that encompasses an object's properties and the values those properties have. This is object. Other one is a relationship between object classes. Degrees may be unary, binary, ternary, or higher, depicted as a solid line between participating classes. This is called association. So moving further, there is one more poll related to this topic. Answer these questions. They are also related to generalization, association, and aggregation. So abstraction of common features among multiple classes as well as their relationship into a more general classes. It's a generalization or association. The next is a part of relationship between a component object and aggregate object is called aggregation or association. Answer these questions. I'm ending this poll. Kindly answer within 20 seconds. After that, I will be ending this poll. Abstraction of common feature among multiple classes as well as their relationships into a more general class. And other one is a part of relationship between a component object and an aggregate object is called aggregation or association. So what is the answer? I am ending poll. The first question is abstraction of common features among multiple classes as well as their relationship into a more general class is generalization. Other is a part of a relationship between a component object and an aggregate object is called aggregation. So this is the answer. I hope everybody is able to see this screen on the creatively. UML diagram type guides learn about all types of UML diagrams with example. So here you can find a number of why I'm showing you that you can find a everybody can see this website related to UML diagram type guide. I hope I'm sharing the screen. There are a number of diagrams, structure related diagrams and behavior related diagrams. So on clicking on these diagrams, you will get an idea how you can draw a diagram for a particular system of your own. This is like I am clicking on the class diagram for ordering system. This is shown here. Other component diagram is shown here. Deployment diagram is shown here. And object diagram is shown here. You can also draw these diagram or get an idea for a particular problem how you can draw for your problem, for your system, for your project basically. So नहीं show रहा is you are not able to see on the screen.
No, ma'am.
Let me see. Mm, can you see now?
Yes, ma'am.
Okay. This is the link Creately, and this blog has all the diagrams like class diagram, component diagram, deployment diagram, object diagram, package diagram, profile diagram, use case diagram, activity diagram, state machine diagram, sequence diagram. These all diagrams are available here, but the the diagrams that are in your syllabus, yet then that you need to focus on is class diagram, component diagram, object diagram, use case diagram, sequence diagram, state machine diagram, activity diagram. These are the diagrams you need to focus on. UML diagram type, structural diagram, behavioral diagram. They have divided into structural and behavioral. These diagrams represent the structure of the system, and these represent how it behaves, the things behave, how the state behave, how the entities behave, how the relationship behaves in the behavioral diagrams. So here all the diagrams are available. You can get an idea for your problem that how you can draw that different diagram for your problem. And this is we can say these are the practical things that you need to draw in the software called Microsoft Visio in future. After doing this open proj, as I have given you one PPT and PDF in the form of PDF, the first lecture related to open proj. After doing this open proj, you are to draw all these diagrams in Microsoft Visio. This software is freely available on the internet, and this software provide you all these components. And using these things, these icons, you are to draw these diagrams for your problem. This is basically a case study you are to do in your lab part, in the part B. So these are the diagram. Timing diagram, you need not to draw the timing diagram. You are to draw only the use case diagram. I am again repeating. If anybody is not able to hear, can tell me through chat or through by raising hand if he or she is not able to see on the screen. These are the links to the all the diagram. This is not only the single link available. We can have different links, like there is another link, UML diagrams. Can you see this link? This will provide you the whole information related to unified modeling language. Can you see this UML diagrams.org on the screen?
Yes, ma'am.
Yes,
Okay.
ma'am.
From here you can get an idea about what is UML, Unified Modeling Language, what is the RUP, Rational Unified Process, the various versions of UML, and the various UML diagrams, generalization set, use case diagram, association, component diagrams, and all these things will be available here. Package diagram, activity diagram, sequence diagram. If I click on the sequence diagram, it will display me the sequence diagram. Let me see this. This is a sequence diagram shown here. These are the objects and all this work. This represents the activation. As I already told you, this bar represents the activation. So in this way, you can see all these diagrams and can understand what these things mean, like lifelines and what are the various components. Here you can see in this table they have shown you what is use case, what is the name, why it is used, what are the components, elements of it, and what is the purpose of that particular diagram. So you can also take a printout of these things, like what is the name of particular diagram, what is the purpose, and what are the components of particular diagram. And you can also draw various diagram. More you draw the diagram, more you will be clear with the idea that of drawing your drawing diagram for your problem. It is just a practice. You need to do practice for these diagrams. It will not you will not be able to draw a diagram in a single day. So study these diagrams, and I hope everybody is clear with these diagrams, and we're moving towards the next lecture in the next class. And do tell me in the next class, we'll be discussing the topic that was left in the previous lecture, that is cohesion. We are done with coupling. We are done with the cohesion, and after that we are to discuss the properties of types of coupling, and that was not discussed in the previous lectures. We'll be discussing those types of coupling, and we'll discuss the new topic in the new lecture. Thank you very much. Thank you, students.